Hey guys, welcome back. We'll continue with the book Cracking Codes with Python, and in this video we're going to focus on how to decrypt messages using the Transposition Cipher. After covering how to encrypt messages with the Transposition Cipher, in this video we're going to focus on how to decrypt messages. To follow along, you can head over to inventwithpython.com. The link is also in the description down below. Now, unlike the Caesar cipher that we saw before, the decryption process for the Transposition Cipher is different from the encryption process. To decrypt an encrypted message, such as this ciphertext over here, we assume that the person doing the decryption has a secret key, in this case 8, provided, and as with encryption, they're going to draw a matrix. Now, in order to determine the boxes they need to draw, they first must divide the length of the ciphertext message by the key and round up to the nearest whole number if the result isn't already a whole number. So in our example over here, the length of the ciphertext is 30 characters, and since the key is 8, we're going to divide 30 by 8, and this gives us 3.75. So we're going to round up to 4. So that means we are going to have 4 different columns, and of course we have 8 rows, which corresponds to the key that we are using. Now, since the length of our message is 30 characters, and we do this 4 by 8 matrix, we know that we have 32 boxes, but since we only have 30 characters, we can gray out the last 2 boxes. After that, we're going to take our ciphertext here, and we're going to start filling out the boxes 1 character at a time. So in this case, we would start out with the C, then add the E, N, O, and we would continue in the second row after that. And we'll keep on going until we filled out all the different boxes. Now, once we've done that, we can have a look at the text from top to bottom. So if we read this, we can see we get back common sense is not so common. So this is the original message we started with. So now that we understood how the steps work in general, we can reflect that in code and write a program for this. For that, we can head over to idle and then create a new file. We're going to call the file transposition decrypt.py. Just as before, we are starting out by importing the paperclip module so that we can very easily copy our decrypted message and paste it, for example, into an email. We're also going to import another module, the math module, which we need for rounding numbers. Then we have 2 separate functions again, the main function, where the execution of our program starts, and the decrypt message function, which accepts a key and a message. We first define the myMessage variable, which contains the ciphertext, and we also have a variable that is holding our key, in this case 8. In order to decrypt the message and store the result as plain text, we are calling decrypt message, and we pass the key 8 and the encrypted message as arguments to that function. Now, after the function is executed and returns a value that's stored in plain text, we are then going to print out the plain text. And again, we're going to have a pipe character at the end to signify if there are any spaces at the very end of our plaintext string. And then we are calling the copy function on paperclip, passing the plaintext to it so we can directly paste the result into some other application, for example. So let's have a closer look at our decrypt message function, which again we call in order to decrypt the ciphertext and store the result back in plaintext. Now, as we know, we first need to calculate the number of columns by dividing the length of the message, in our example before 30 characters, by the key, which was set to 8 before, and we got back 3.75, which we then rounded up to 4. We can express that in code by using the ceil function. The ceil function takes a number and rounds it up to the next integer number. So 3.75, for example, will be rounded up to 4. Now we then pass the length of the message to it, divided by the key. So we know that our message has 30 characters. So by calling len on message, we get back a value of 30, and we are dividing that by the key, which is a value of 8. Here we are casting the key as a float. This turns our integer value of the key, 8, into a float value, 8.0. And this is just to ensure that we actually end up getting a decimal number and don't lose any digits. Now after that, dividing 30 by 8, we're going to get 3.75. We call ceil function, which is part of the math module, and at the end we turn that into an integer. So we have the value of 4, and that is stored in the number of columns. The number of rows, of course, corresponds to the number of keys, which is exactly what we saw before. We have the 4 columns here, and then we have 8 rows, which matches our key number. Now we also need to determine how many shaded boxes we have. For that we multiply the number of columns by the number of rows to get the total number of boxes. So 4 times 8 is 32, and then we are going to subtract the length of the message, so 30 characters. So we know we don't need 2 of the boxes, and they are going to be grayed out. Now as before, we are going to use lists in order to represent a column in the grid. So for that we are going to multiply a list with an empty string with the number of columns, so in our case 4, and this is going to construct the different columns that we're going to work with. Now after that we need to keep track of which column and which row we are in. So we are going to start with a value of 0 for the column and the row, indicating the top left cell up here. After that we are looping over each individual character in our message, so over all 30 characters. And we are adding each individual character as we go through the characters in our message to the correct list. For that we are referencing the elements inside our list. So in the beginning, of course, we have 4 empty strings by referencing that by index. So in the beginning, column has a value of 0. So we're going to reference the very first string inside of our plain text list. And then as we are going to increment the number of columns, of course, we are going to add characters to the other strings as well inside of our list. So in fact, once we added a character to our first list element, we are then going to increment the value of column by 1. And that ensures that we are moving from left to right in the different rows. So we start out with the first column here, then we switch over to the second column, and so on and so forth. Of course, once we are here at the last column, we need to make sure that we continue with the first column again. And this is what this if statement is for. So here we are checking if the currently selected column that we are in is equal to the number of columns. That would mean since column starts with a value of 0, once we're in the last column here, our column variable would have a value of 3. So 0, 1, 2, 3. And if we increase it once again, we would have a value of 4, which would be equal to number of columns, the variable over here. So if that's the case, we are going to set column to 0 again, because we want to start from the next row. And of course we also need to indicate that we don't overwrite what we just added, but that we switch over to the second row. So therefore we are increasing the value of row by 1. And this is how we ensure that we basically move 1 row down and start at the first column again once we are at the end of the row. Now of course we still have those 2 gray boxes here, and we need to make sure that we don't write inside of those gray boxes, but instead that if there's a gray box we just switch over to the next row immediately and then continue adding our characters. To ensure that, we have this second condition here, and here we are checking whether we are in the last column by checking whether the value for column is equal to num of columns minus 1. So that would mean that if we have 4 columns, that column has a value of 3. So 0, 1, 2, 3. And if we are in that last column, we are checking additionally if row is greater than or equal to the number of rows, in our case 8, equal to the key, minus the number of shaded boxes, which we know is 2. So if the row is greater than or equal to 6, 1, 2, 3, 4, 5, 6, so down below, and then we know we have a grayed out box here. And in that case, we are also going to set the column to 0 and increase the row by 1. So in that special case that we have a grayed out box, we wouldn't go to the last column, but instead jump to the next row right away. And of course we're going to do a little bit more of a deep dive into this construct here and also have a look at what the OR and AND statement actually mean. Now after running through that for loop for all the individual characters, we're going to end up with a list of 4 different elements containing different strings. Specifically, we have the first column here with this string, then we have the second column here with this string, a third string and a fourth string, and of course we still need to add them together. So for that, again, we are going to use the join function that we learned about before, and we're going to pass a plain text, which of course is our list that we constructed with the 4 separate strings in it. and we're going to join that together so it's actually a sentence. And as before, we still need to make sure that we have this if statement in here so that our program starts and works properly. Now with this in place, let's actually make sure that our program runs properly. For that we can simply press F5, and here we can see our message. Common sense is not so common. So our encrypted message up here, our ciphertext, was decrypted properly. Now that we know that our program works properly, let's dive into the new concepts we learned about. And the first one of those is our Math.ceil function that we worked with before. So let's head over to idle to have a closer look at that. In the interactive shell, we can, for example, divide two numbers. For example, we can divide 21 by 7. We get back a value of 3.0. And of course, we can also have a division which does not return a whole number. So if we divide 22 by 5, we can see we get back 4.4. Now we could of course use the round function to round those. So for example, we could pass a value such as 4.2 to the round function, and we can see it rounds down in this case to a value of 4. If instead we pass a value of 4.9 to the round function, we would get back 5. So it's doing exactly what we would expect. If we have a value of 0.5 or higher, it would round up. And if we have a value of 0.4 or lower, it would round down. But in our example before, we always want to round up. So even for a value of 4.2, we want to round this up to 5, because otherwise we won't be able to decrypt our message. And for that we need this special ceil function. And in order to use that, we first need to make sure that we import the math module. Once we have done that, we can use it by typing in math, period, and then the function we want to use. So if we use the ceil function and we type in 4.2, rather than getting a value of 4, we instead get a value of 5. By the way, if we always want to round down, we would use the floor function instead. So even if we have a value of 4.9, it would always be rounded down to the lower value, so in this case to 4. If instead we use the ceil function on 4.9, of course we're going to get back 5. Now this explains the ceil function we've been using here. The other aspect that might be unclear is this if statement here. We have a number of different Boolean expressions. So in this case we are checking whether column has a value of num of columns, or for example whether row is greater than or equal num of rows minus num of shaded boxes. And for Boolean expressions, we always get back a value of true if the expression is true and otherwise false. So if we type in 5 greater than 3, that of course is true, so we are going to get the Boolean value true back. And of course we can also check if two values are equal. So in the case of the column, we can for example check if both variables have a value of 4, and if that evaluates to true, then of course the block inside the if statement will be executed. We also have this or and operator that we are using, and in the case of the or Boolean operator, either one of the conditions to the left or right of it need to be true to execute that statement. So that means if column is equal to num of columns, for example if column has a value of 4 and num of columns also has a value of 4, then this expression will evaluate to true. And since for the or statement just one of the two expressions needs to evaluate to true, we already know that the block inside of that if statement will be executed. So therefore the second part wouldn't even be evaluated. But the end statement here actually requires that both statements to the left and right evaluate to true. So in this case here, column equals num of columns minus 1 needs to be true, and also row must be greater than or equal to num of rows minus num of shaded boxes. If either one of those two expressions, this one here in front of the end statement or the other one after the end statement, evaluate to false, then the entire expression will evaluate to false and will not be executed. In fact, we can construct such a truth table where we can see if two expressions, a and b, evaluate to true depending on the value of a and b. So for example, true and true will evaluate to true, and everything else that includes false, so true and false and true, or false and false, will always evaluate to false. And that's of course because both Boolean expressions in an end statement need to evaluate to true for the entire expression to evaluate to true. On the other hand, if we are working with an or operator, then just one of the two expressions needs to evaluate to true. So true or true is equal to true, but also true or false will evaluate to true, and also false or true. Only in the case that we have two false statements, false or false, will the entire expression evaluate to false. So to make it a little bit more clear, here we have the or statement. So if this statement here is false, and also this other statement after the or statement is false, in that case the entire expression will evaluate to false and will not be executed. But if either one, this one in front of the or statement or this one after it, evaluate to true, then the entire expression will evaluate to true and that block will be executed. The AND and OR operators are simply shortcuts that we can use. And to test that, we can type some code into our interactive shell. So let's say we want to check whether 10 is greater than 5 and also 2 is less than 4. We could simply nest two if statements inside of each other. So if 10 is greater than 5, if that evaluates to true, then of course we're going to execute the code inside of that if statement. And the first row is another if statement. So here we are checking if 2 is less than 4. If that's true, we're going to print hello. And if that's not true, then of course the block inside of the if statement won't be executed. So let's run the program. And we can see that hello is printed because the first statement is true and also the second statement. We can rewrite that and make it a little easier to read by using the AND keyword. And here we are simply typing if 10 is greater than 5, which was the first if statement, and 2 is less than 4, which is the second if statement, then we're going to print hello. But this is basically the same as what we wrote up here. In fact, if the first statement here evaluates to false, so let's say we switch those numbers, if 5 is greater than 10, which evaluates to false, then the rest of the statement won't even be evaluated because we have an AND keyword here and we know that both sides need to be true in order for the entire expression to be true. So therefore, the second part wouldn't even be evaluated, just as up here. So if we had if 5 greater than 10 here, then this evaluates to false, of course, and the rest of the statement won't even be evaluated. So if we press enter here, we can see hello is printed as well. So those two expressions are basically equivalent. Let's have a look at the practice questions. The first exercise is to use paper and pencil to decrypt a number of different messages with a key of 9. So this is the first message and we know that it has 89 characters and we should use a key of 9. With what we learned before, we need to first take the number of characters, 89, and divide it by the key, and then round it up to the nearest number to get the number of columns that we need for our table. So let's do that. Let's take a number 89, the number of characters. Let's divide it by 9, and we can see we get back a value of 9.88 and so on and so forth. So that should be rounded up to 10. So therefore we need 10 columns and 9 rows because the number of rows is always equal to the number of keys. So we can create such a table with 10 columns and 9 rows, and we also need to calculate the number of shaded boxes that we won't need. We get that by taking the number of boxes, by multiplying the number of rows, 9, by the number of columns, 10, so we get a value of 90. We know that we had 89 characters, so therefore the difference is a value of 1, and we know the very last box here then needs to be grayed out. Now after that we can start with the first character, H, type it in here, then we have a space, then we have C, B, and we would continue doing that, filling out each cell in the row, and once the row is filled out we would continue with the next row. And doing that for the entire table will give us this result here. Once we've done that, we can read from the first column from the top to the bottom and then continue with the second column. So here we can see the decrypted message is he picked up the acorn and buried it straight by the side of a river, both deep and great. And we have the period at the end. So this is how we would go about decrypting the message. And of course we could do the same steps for the second and the third text here, which I'm going to skip for now. Now the next exercise is when you enter the following code into the interactive shell, what does each line print? We are using the Math module here that we learned about before, and at first we are going to use this ceil function. Now we know that the ceil function always rounds up. We have been using it before in our program, so we know that we have a value of 3.0. The ceil function will always round up to the nearest integer value. However, in this case we provide a value of 3.0 So this already is an integer number. So therefore calling ceil in this case will actually round to 3. If we changed it to 3.1, however, the result would be 4. So let's verify that by opening our interactive shell. And we're going to start out by importing the math module. And then we can go ahead and we can use the ceil function, type in a value of 3.0, and we can see we get back a value of 3. Next up, we're using the floor function. And we know that the floor function basically does the opposite of the ceil function. This one will always round down to the next integer. So in this case here, we are using math floor with a value of 3.1. So we should get back a value of 3. Let's verify that. And indeed, we get the value of 3 returned to us. Next up, we're using the regular round function. And the regular round function will always round down or up, depending on if the value is greater than or lower than 0.5. So at first we are rounding the value of 3.1, so we should be rounding down to 3. And if we type that into our interactive shell, we can indeed see that we get back a value of 3. Now in the next example here, we have a value of 3.5, and we know that starting from 0.5, you would always round up. So in this case, we should get back a value of 4, which is returned to us here. After that, we have a bunch of different Boolean statements, and we should say what they evaluate to. So first we have the logical AND operator, false and false. And we know that for the logical AND operator, if either one of the two expressions evaluates to false, then the entire expression will evaluate to false. So false and false will evaluate to false, which we can of course verify in our interactive shell. And then next up we can check if false or false evaluates to true or false. We know that with the OR statement, just one of the two expressions needs to evaluate to true for the entire expression to evaluate to true. Now in this case though, both expressions are false, so therefore the entire expression will be false as well. Let's check that into your interactive shell and we can see that's indeed the case. Now next up we have not true. So we know that not reverses the Boolean result, so not true would be false. But then we have another not statement, so therefore not true, this will be false. But with another not in front of it, that will turn the value again, so that would indeed be true. Let's check that in our interactive shell, and we can indeed see that we get back a value of true. Now the next exercise asks us to draw the truth tables for the AND, OR and NOT operators. Here we have the truth table for the AND operator, so we know that only true and true will evaluate to true, and as soon as there's at least one of the expressions false, then the entire statement will evaluate to false. So only in one case we have true as the end result. The OR operator truth table is basically the other way around. Here everything is true except for if you have false or false as a statement. And the reason is that if at least one of the two sides in the expression evaluates to true, then the entire expression will evaluate to true. So it's sort of the opposite of the AND truth table. And finally we have the NOT operator truth table. In this case, the Boolean expression will always be reversed, so not true evaluates to false, and not false evaluates to true. And finally, we have the question which of those if statements here is correct. Is it if underscore underscore name underscore underscore equals equals and then main? Or is it a variation of that? And of course, we know we always need to have two underscores, and we are generally setting the name variable here, so therefore the first expression here is actually the correct one. And if we open our program again, of course we know that this is the if statement that we always have at the very end of our program to make sure that we are executing the main function at the start of our program. We learned how to decrypt a message that has been encrypted with the transposition cipher, and we also learned about some additional programming concepts. In the next video we're going to learn how to automate our programs and test them. Feel free to subscribe to the channel to stay up to date, and see you guys in the next video.